Hi, Courtney. Yeah, so here's your problem that you emailed me, where f of x is set to be 4x squared plus 4x plus 2, and g of 2 they gave you, so they didn't give you the function g, they just gave you the result when x is 2. So g of 2 is negative 3, and they gave you what the result when x is 2 in the derivative of g prime of 2 equals negative 2. So not a ton of information for g of x, but the function f of x we know. And they asked us to find the quotient of f of x and g of x. So we wanted to find the derivative of this function h of x. So I've got something written here. You do not have to use this. However, just putting it out there for you. When I was taught this, and the way I still say it in my head when I'm using the quotient rule, is the numerator and the denominator of your quotient is high and ho, because it's easy to remember, kind of like the dwarves in Snow White. So we've got high and ho. It's ho d high minus high d ho over ho ho. That's how I still think about it. What that relates to in terms of the more rigorous mathematics is that the derivative, this should have, there we go. The derivative of h of x is going to be ho, which is the bottom, so g of x times the derivative of the numerator minus the numerator times the derivative of the denominator. So I'm using the cursor here as my pointer, all over the denominator squared. So saying numerator, derivative of denominator, denominator squared, just doesn't roll off the tongue as nicely as ho d high minus high d ho over ho ho. So you do not by any means have to use this, but this is how it rings in my head, and this is how it looks algebraically, or more rigorously. So let's fill in the blanks. We know g of x. Oh, excuse me, they don't ask us for the derivative of h of x. They ask us for to evaluate when h of x is 2. So really we're looking at g of 2 times the derivative of f at 2 minus f at 2 times the derivative of g at 2 all over g at 2 squared. So we're just filling in the blanks, saying we know that x is going to be 2, so we just put a 2 in for all of them. And some of these we know. We know g at 2 is negative 3. So we know the first part. We don't know the derivative of f at 2. We don't know f at 2. We know the derivative of g at 2. That's up here, negative 2. And we know g at 2 again. We already have that. That's negative 3. So I need to find f at 2 and the derivative of f at 2. Those are the two pieces of information I need. So if I plug in 2 to this function f of x up here, I've got 4 times 2 squared plus 4 times 2 plus 2, which should work out to 26. My mental math worked out okay there, and I think it is. So we got 4 times 4 is 16, plus 8 is going to give us 24, plus 2, 26. There we go. And then the derivative of f. And so I'm not going to get into this too much, but if you use the power rule, I believe, we can bring the 2 down and say we have 4 times 2 is 8, and subtract 1 from the exponent here, and we end up with 8x plus 4. Same thing, bring the 1 down, times 4 is 4, subtract 1, we get 0 x's there. So we've got the derivative of x right there. If I plug in 2, 8 times 2 is 16, plus 4 should be 20. So now I know all the parts I need in this whole equation here. I know g at 2, f prime at 2, f of 2, g prime at 2, and g of 2 squared. Filling in the blanks. Here was that equation with all the 2's. I'm just going to fill in all 1, 2, 3, 4, 5 parts. 1, 2, 3, 4, 5. If you use a calculator, do it in your head or on paper, negative 3 times 20 is 60, negative 60. 26 times negative 2 is negative 52. And if you add those together, you get negative 8. Negative 3 times negative 3 is a positive 9. Be careful that negative 3 squared is not negative 9. It's a negative 3 times itself, which gives us positive 9. Now, I couldn't find this in your list here. I get to look at all the problems that you've done and haven't done. I couldn't find this one, so that's what I'm getting. If for some reason I made a mistake, I did some arithmetic wrong, and you're looking at your screen and saying, nope, I didn't get, or the Newton site did not give me -8/9, let me know, please. But this should be it. This is how those blanks are filled in. If you need more of an explanation, or if you're struggling when they combine, I know some of these problems, they combine the uh, product and the quotient rules together into one big giant problem. I think this is an example of that right there. So if they do this and they ask you to find that, and you're confused, or you're lost, let me know and I'll make another video for you.